In this presentation, you will learn the basics of UML required to interpret and create class diagrams. Let's get started. An abstract class is represented in UML as shown in this diagram. Note that the class name command is in italics. The method execute is shown in italics to indicate that it is abstract. In this next slide, the variable analog is static, and this is shown by underlining the variable. The / indicates a derived element. In this case, sequential is a derived attribute. Start command is a concrete class, and it extends the abstract class command. The arrow shown indicates the generalization relationship between the command and start command classes. In the next slide, you can see the syntax for showing the class name and the object name. This is usually shown in a sequence diagram. A note is a symbol for displaying a comment or other textual information, such as a method body or a constraint. Depending on the case tool that you use, the notation may differ. For example, private attribute can be indicated with a minus sign, but the case tool may use an icon, which is different than the minus symbol. So let's move on to some interesting notation without getting bogged down in minute details of the UML. Association is defined as the semantic relationship between two or more classifiers that describes connections among their instances. Associations are the glue that holds together a system. Without associations, there is only a set of unconnected classes. An association is one of the principal types of static relationships. It represents relationships between instances of classes. From conceptual view, the association represents conceptual relationship between conceptual classes. You don't show methods in this view. From specification view, the association represents responsibilities. You show methods in this view, but you don't care about data structure in this view. Consider an example. A person owns a car. The instance of a person class can answer questions like, how many cars do you own? What color is your car? And so on. These are the responsibilities of the person class in specification view. This is due to the navigability from person to car classes. From implementation view, we could have pointers or references to associate the participating classes in a relationship. You do care and decide about the data structure that's used to implement the cardinalities between the classes. Navigability indicates whether it's possible to traverse a binary association within expressions of a class to obtain the object or set of objects associated with an instance of the class. In the next slide, the navigable association is shown with an arrowhead on the end of the association path attached to the target class, which is account. The arrow indicates the direction of traversal. If the navigation is possible in both directions,